If you stand at SpaceX's Starbase launch site in Boca Chica, Texas, you will see one of the great spectacles in the history of human industry. On one side, a giant Starship rocket towers dozens of stories high, shining in silver. At its feet, there is always a row of equally shiny, sharp-edged Cybertrucks. Is that just a coincidence? Or is it Elon Musk's strange personal taste in design? If you only look at the surface, you are being fooled. Peel back that stainless steel shell, and you will find a fact that Wall Street has largely ignored. These machines actually belong to the same industrial organism. They do not just share materials. At the microscopic level, they share atoms. At the macroscopic level, they share a brain. SpaceX and Tesla have never really been two separate companies. They are two avatars of the same cross-planetary industrial entity. This tight coupling gives them unbeatable efficiency. It also plants huge risks that could lead to systemic resonance. Hi, this is Money Stories. In the previous video, we opened up our imagination and broke down how SpaceX could evolve into a trillion-dollar interstellar entity. Today, we are bringing the camera back down to Earth, but our perspective is still in the sky. We are going to focus on Tesla. We will explore one core question. How will SpaceX, this seemingly independent space giant, gradually evolve into Tesla's deepest and widest technology moat? At the same time, why could it also become Tesla's biggest financial risk in the future? To solve this puzzle, we first need a key. There is one soul that runs through Musk's entire business empire. First principles. You have probably heard this phrase in countless interviews and articles. It has even become an overused business buzzword. Today, we will drop the mystical explanations and actually use it as a scalpel. Traditional business analysis relies on analogy. Analysts say Tesla is the Apple of the car industry, or SpaceX is the FedEx of space. This way of thinking is convenient, but it only lets you see the past. It cannot help you see the future. Inside the Musk ecosystem, analogy completely breaks down. We need to think like physicists. Strip things down to the most basic physical facts. Then reason upward from there. The question is not how do others do it. The question is, within the limits of physical law, what is the absolute limit of this thing? Let's start at the most basic level of the material world, the level of atoms. Imagine you are now a top engineer working for Musk. You receive two tasks that sound completely unrelated. Task 1, build a heavy lift rocket that can carry people to Mars and be reused. Task 2, build an electric pickup truck that can drive on any road and even be bulletproof. If you are a traditional, experience-driven engineer, what would you do? You would set up two completely separate teams and two completely separate supply chains. The rocket team would tell you that the core pain point in aerospace is weight. To make it light, you must use carbon fiber composites. They are insanely expensive. They are extremely hard to work with. They tend to delaminate under atmospheric heating. But this is the golden rule of the space industry. The car team would tell you that the core pain point in cars is cost. To make it cheap, you use ordinary stamped steel, or you use some aluminum alloy for performance. As for carbon fiber, that is for supercars. For mass market vehicles, forget it. Following that logic, these two companies would have no overlap in business at all, other than sharing the same boss. In fact, in the early days of Starship development, SpaceX really did try to build huge carbon fiber propellant tanks. They even bought the world's largest carbon fiber winding machine. They burned through hundreds of millions of dollars in several years on that path. But first principles thinking forced Musk to stop when they hit a wall. He started to re-examine the physical properties of materials, not by reading what the textbook says, but by looking at the raw data of the materials themselves. The team discovered a crucial physical trade-off. At room temperature, carbon fiber does crush stainless steel in terms of strength-to-weight ratio. But rockets do not spend most of their time at room temperature. Their tanks are filled with liquid oxygen and liquid methane at minus 160 to 200 degrees Celsius. In that deep cryogenic environment, carbon fiber does not get stronger. It faces micro-cracking and fuel permeation risks. That forces engineers to add extra liners or thickness margins. Now look at 300 series stainless steel. It has a magical, low-temperature strengthening effect. As the temperature drops, its strength increases dramatically by up to 50%, while still keeping very high toughness. It does not suffer from the cold brittleness that normal steel has. This means that when the rocket is fully fueled and under maximum load, you can actually make the steel walls very thin, only about 4 millimeters. The result is surprising. The stainless steel itself is heavy, but because you can use so little of it, and you do not need to worry about permeation, like with carbon fiber, the overall structural efficiency of the system can rival the expensive and complex carbon fiber solution. There is more. A rocket does not only face the cold of space, it also faces the heat of re-entry. When Starship re-enters the atmosphere, the windward side can reach temperatures of over 1,000 degrees Celsius. Carbon fiber would have long since carbonized at that temperature. Aluminum alloys would melt into a puddle. You normally need thick, fragile thermal tiles like the space shuttle. That is a maintenance nightmare. Stainless steel has a very high melting point. It can tank that heat. This means Starship only needs a small number of heat shield tiles in key areas. It may not need a complex thermal protection system at all. So, if physics tells us that stainless steel is the best choice for a Mars rocket, here comes the leap in thinking. Why not use this space-grade material to build a car? That is the real origin of the Cybertruck. When you look at the Cybertruck's cold-rolled stainless steel exoskeleton, what you are actually seeing is Starship technology being directly handed down. This is not a metaphor. It is a naked engineering fact. Tesla and SpaceX share one of the world's top materials science teams. This team is led by Dr. Charles Kuehmann. His title is interesting. He is Vice President of Materials Engineering at both companies at the same time. This is almost unheard of in modern business history. It is like Apple and Boeing sharing the same Chief Materials Officer, developing a brand new alloy that can handle extreme space environments and also meet the needs of high-volume car manufacturing. An alloy called 30X requires massive investment. It involves countless formula tweaks, casting experiments, and cold rolling process tests. If you spread that huge research and development cost over any single product, it becomes an unbearable sunk cost. But because these two companies exist together, that cost is spread across two potential trillion-dollar markets. For Tesla shareholders, the economics behind this are very attractive. The Cybertruck you buy, with that insanely hard, bullet-resistant body that normal stamping presses cannot even form, was effectively subsidized by SpaceX's Mars colonization program. Without Starship's extreme exploration of stainless steel, the Cybertruck might have stayed as a concept sketch on paper, or it would have become a normal aluminum pickup. And this synergy is not just about sharing technology, it is also a supply chain dimensionality reduction attack. Let's talk about economies of scale and microeconomics. SpaceX is a space giant, but even if it builds dozens of Starships a year, that purchase volume is still tiny for global steel giants. It has almost no bargaining power. Steel mills will not open a dedicated production line for a special stainless steel formula just for your small order. But what if you add Tesla? What if Tesla builds 200,000, 500,000, or even 1 million Cybertrucks a year? The order size changes overnight. The combined raw material demand of these two companies becomes a huge bargaining chip. They can buy the highest spec custom steel at prices far below what a single space company could get, possibly even below what traditional car makers pay. This cross-industry purchasing leverage leaves competitors with no way to match them. We have talked about atoms and materials. Now let's walk into the factories and look at the machines that build the machines. In Texas, SpaceX is building its Star Factory. Its goal sounds like the ravings of a madman. Build 1 Starship per day. In traditional aerospace, the cycle to build a heavy rocket is measured in years, even decades. NASA's SLS rocket takes several years to build a single unit. But if you take off your aerospace glasses and put on automotive glasses, daily production is nothing special. In a car factory, that is normal. It might even be considered slow. This is why SpaceX is rapidly becoming the ultimate incubator for Tesla's frontier manufacturing technology. It is also Tesla's training ground for manufacturing philosophy. There are more and more signs that Tesla's automation engineers, who were battle-hardened in the production hell of the Nevada and Fremont factories, are deeply involved in designing SpaceX's production lines. They are transplanting mature automotive technologies into the rough world of rocket manufacturing. Robot welding arms, high-precision vision inspection systems, complex logistics, automation algorithms. If you look inside the Star Factory, it looks more and more like a Tesla gigafactory. Giant coils of steel go in, automated lines turn them into cylindrical sections. Then robots stack and weld them like Lego bricks. In the other direction, SpaceX's aggressive culture of rapid iteration, blow it up and build the next one, is reshaping Tesla's DNA. Traditional car makers, like Volkswagen or GM, value stability. A new model takes 5 or 6 years to develop. It is tested endlessly before launch, because a recall is a disaster. Tesla's becoming more like a software company, even like a rocket company. Look at the 4680 structural battery pack. It turns the battery pack into a structural part of the car body. That is exactly the design logic of a rocket's monocoque structure. Look at the newly announced Cybercab. It boldly removes the steering wheel and pedals. This courage to fundamentally re-architect hardware comes from first principles thinking in aerospace. If I can solve this with software, why keep this mechanical part? This cultural cross-pollination is the core force that lets Tesla stay a technology growth stock instead of becoming a traditional manufacturer that just piles on features. Next, let's lift our eyes off the surface of the Earth and look into deep space. There is a field that many people care about, but that is full of misunderstanding. Space artificial intelligence. Many people think space AI is pure science fiction, or just a buzzword to attract investment. Under a first principles framework, it is actually a rational extrapolation based on energy capture efficiency and the physics of heat dissipation. It is the inevitable destination of compute. Musk has predicted that in the future, the cost-effectiveness of running large-scale AI systems in orbit will surpass that on Earth. That sounds counterintuitive. On Earth, we have existing power grids. We have maintenance staff on call. We have cheap water cooling. Why launch insanely expensive servers into space? To understand this, we have to go back to physics. What is AI training at its core? It is the conversion of energy into information. Training a large model consumes enormous amounts of electricity. On the surface of the Earth, harvesting solar energy is very inefficient. The Earth rotates. There is day and night. Solar panels only work about half the time. The atmosphere scatters and absorbs sunlight. Weather and clouds block the sun, so the average utilization of solar energy on the ground is very low. You need huge panel areas and expensive batteries to handle nighttime. In orbit, especially in certain sun-synchronous orbits, the situation is completely different. Solar panels there can receive sunlight at several times the intensity of the ground, almost 24 hours a day. That is truly unlimited, continuous, clean, free energy. The 1,366 watts per square meter of the solar constant is an energy goldmine that the Earth's surface cannot map. Of course, sharp listeners will object. Heat dissipation in space is a nightmare. On Earth, we use water cooling and air cooling. Air and water are great heat conductors. In a vacuum, there is no air convection. How do you get rid of heat? According to thermodynamics, in a vacuum, you can only dissipate heat by radiation. That is much less efficient than convection. In the past, this was the fatal flaw of space data centers. To keep servers from burning up, you would need huge radiators. Launching several tons of radiators into orbit was economically impossible. Starship changes the boundary conditions of that equation. When launch costs drop from $10,000 or $20,000 per kilogram to around $100 per kilogram, or even lower, the physical constraint gets broken by economics. It becomes feasible to launch hundreds of tons of giant foldable radiators into orbit with areas as large as a football field. This opens a door to the future for Tesla. We know Tesla built the Dojo supercomputer to train its self-driving system. Dojo chips use a unique system-on-wafer packaging. They chase extreme compute density and bandwidth. If SpaceX really builds zero-carbon, zero-water consumption data centers in orbit, the hardware running inside them is very likely to be Tesla's Dojo chips. Dojo's architecture is designed for high-throughput AI training. That matches space computing needs perfectly. There is another very strategic detail that I want to highlight. Many people may have missed this. SpaceX is investing over $280 million to build and expand a large advanced semiconductor packaging and PCB manufacturing facility in Bastrop, Texas. That is right next to Tesla's Giga Texas factory. It has received $17.3 million in subsidies from the Texas government. The goal is to become the largest printed circuit board and panel-level fan-out packaging base in North America. Why would a rocket company cross over into precision electronics manufacturing? It looks off-mission. From a first principles view, this is the inevitable result of Starlink's explosive growth. To produce tens of thousands of user terminals per day, SpaceX must master core beamforming chip packaging technology. It needs to cut costs and reduce dependence on Asian supply chains, especially Taiwan and Malaysia. Internalizing advanced packaging is a necessary step to de-risk in today's geopolitical environment. Officially, this facility mainly serves Starlink. Tesla also has its own Terafab fab plan, targeting 100,000 wafers per month. But the strategic meaning here is intriguing. The two sites are so close geographically. That shows Musk's extreme focus on localizing and securing his supply chain. If TSMC or other key suppliers face major geopolitical disruptions in the future, this in-house advanced packaging capability at SpaceX could, in theory, provide critical backup support for other projects in the Musk ecosystem, including Tesla's AI chips. This kind of deeply planned vertical integration is the scariest moat of the Musk empire. This builds a grand business picture. Tesla is no longer just a car company. It is becoming the hardware architect of the world's largest distributed compute network. Every Starlink satellite launch could be a deployment of Tesla's Dojo architecture in orbit. Musk has even floated a disruptive idea called the Heart of the Galaxy project. In the future, space solar power does not need to convert electricity into microwaves and beam it back to Earth. The losses are too high, the equipment is too complex. We can use that electricity directly in space for computation. We train cutting-edge AI models in orbit, then we send the high-value data, the trained model weights, back to Earth at the speed of light through Starlink's laser links. Data transmission has essentially zero loss. What does this mean for Tesla? It means Tesla's AI training costs could drop sharply as orbital computing spreads. They could even approach zero. For Tesla, which is sprinting toward AGI and full self-driving, that is a nuclear-level competitive advantage. Let's pull our view even farther out, past cislunar space, to the moon, then to the red planet, Mars. Here, another controversial Tesla product, the Optimus humanoid robot, will meet its true destiny. On Earth, when we talk about humanoid robots, we always get stuck in debates about cost and practicality. People ask, can this thing really be more efficient than a dedicated robotic arm on a production line? Can it really be cheaper than a minimum wage worker? In a world with abundant human labor, the business logic of humanoid robots still needs time to prove itself. On Mars, that logic flips completely. Think about it. Sending a human astronaut to Mars costs astronomical money. Humans are extremely fragile. To keep one person alive on Mars, you need a pressurized habitat, oxygen recycling, water recovery, food production, thick radiation shielding to block solar wind, and even psychological support. All of that is a constant, massive resource drain. On Mars, humans are negative assets. They must be supported. Optimus robots only need two things: power and maintenance. Even if one Optimus costs $100,000 or $500,000, it is still several orders of magnitude cheaper than human labor in the budget framework of a Mars mission. That is interplanetary labor arbitrage. Musk has already said that Optimus will go to Mars with Starship as early as 2026 for early construction work. They will be the first colonists to land on Mars. They will build bases, lay solar panels, and produce fuel. For Tesla investors, this is an extremely important signal. It is also a huge safety net. It means SpaceX will be the first anchor customer for the Optimus production line. It will also be the least price-sensitive customer. With such a large, guaranteed internal demand, Tesla can invest heavily in large-scale robot production before the consumer market explodes. It can spread out tooling costs, research and development costs, and fixed asset depreciation. While other robot companies are still struggling to find use cases, Tesla's robots already have thousands of Mars orders. And think about this. If Optimus can work reliably on the Moon or Mars, in hellish environments full of sharp dust, with temperatures swinging from plus 20 degrees to minus 100 degrees Celsius, and intense radiation, then when it comes back to Earth to move parts in a factory or do chores in your home, its reliability will be a crushing advantage. That will give Tesla an unbeatable brand moat in the robot market. If I can build a base on Mars, doing your dishes on Earth is nothing. Beyond hardware, let's look at connectivity. This is the bridge between the world of atoms and the world of bits. We know Tesla's FSD, full self-driving, depends on a closed loop of massive data. Collect data, upload to the cloud. Train models, push updates. Right now, this loop is limited by 4G and 5G networks on the ground. If the car drives into a remote area with no signal, data upload stops. If the cell tower is congested, software updates are slow. This is where SpaceX's Starlink direct-to-cell technology comes in. It is not just about sending a text from the wilderness to call for help. For future robotaxi fleets, this is the baseline for safe operation. Imagine your robotaxi blows a tire on a desert highway, or it encounters an extreme situation the system cannot handle. If there is no signal, that is a disaster. Starlink ensures global coverage with no dead zones. Even if the vehicle is driving through the most desolate corner of Earth, Tesla's operations center can monitor it in real time. It can even remotely take over through a low-latency link. Other car makers that rely on third-party carriers like AT&T or Verizon simply do not control this strategic resource. Patent filings show that Tesla has applied for technology to invisibly integrate satellite antennas into the car's roof glass. That is not just for looks, it is for bandwidth. Today's phone-to-satellite links can only handle texts or voice calls. The bandwidth is tiny. A vehicle-grade flat-panel antenna can provide gigabit-level downlink speeds. Imagine millions of Teslas on the road. Every day, they stream rare, high-definition driving scenarios back to Dojo at fiber-like speeds through Starlink that will massively accelerate FSD training and convergence. It will leave competitors far behind. While other cars are waiting for Wi-Fi to download updates, Tesla is evolving on the road. So far, we have seen deep integration between SpaceX and Tesla in 5 dimensions: materials, manufacturing, AI, robotics, connectivity. From an engineering and technology perspective, this is a perfect symbiosis. It is textbook industrial synergy. But as an investor, or as a calm observer, if you hold Tesla stock, you must also see the other side of the coin. From a financial perspective, SpaceX's impact on Tesla is a complex double-edged sword. It could even cause short-term damage. This brings us to the last topic. It is the most realistic and sensitive one: the gravitational pull of capital and valuation games. For a long time, Tesla stock was the only major vehicle in public markets for investors to bet on Musk's vision. People bought Tesla not just for the cars, they bought Musk's sense of the future. They bought his impact on human civilization. Tesla's price-to-earnings ratio, far above traditional car makers, contains an unquantifiable Musk premium. Now the situation is changing. SpaceX has become too successful, it is raising new funding, its valuation is shooting toward $800 billion, there is a high chance it will go public directly in 2026. Once SpaceX is listed, it will offer a purer investment target. It will not be tied to the cyclical auto industry. It will have more imagination. Space transportation, global satellite internet, deep space exploration, even a ticket to AGI. This creates a risk, a liquidity siphon in the capital markets. In simple terms, fund managers and retail investors who bought Tesla to follow Musk may rotate their positions. They may think, if I want to bet on Musk, why buy the car company that is stuck in price wars on Earth? Why not buy the company that is colonizing Mars? They may sell Tesla and buy SpaceX. That would strip the Musk premium out of Tesla's stock. Wall Street might re-rate Tesla. It could be pulled down from the altar and downgraded to an excellent EV and AI company. This narrative shift could put heavy downward pressure on the stock in the short term. As the overlap between the two companies grows, the transparency of related party transactions will also become a focus for Wall Street. It may even become ammunition for short sellers. In the future, if SpaceX buys large numbers of Optimus robots, or if Tesla pays huge satellite service fees to SpaceX, or if they transfer research and development staff between them, how will those deals be priced? Are they fair? The market will ask, is this disguised financial support? Is this profit shifting to dress up one company's financials? Complex group structures like this often get a conglomerate discount. There is another risk we cannot ignore: key person risk. Musk is extraordinary, but he is still human. He has only 24 hours in a day. He runs Tesla, SpaceX, XAI, Neuralink, and more. He also spends a lot of time on social media. The bigger SpaceX's Mars program becomes, and the more frequent its launches, the less time and energy Musk may have for Tesla. Talent can flow between these companies and keep intellectual capital inside the ecosystem. But for a Tesla-only shareholder, the CEO's divided attention is a real concern. On the positive side, there's also a defensive benefit. Most of Musk's personal wealth is locked in the equity of these two companies. In the past, to fund SpaceX's early Mars ambitions, or to buy Twitter, he had to sell Tesla stock several times. That caused violent swings in Tesla's share price. If SpaceX can generate huge positive cash flow through Starlink, and if it can go public and raise capital independently, Musk will be much less likely to use Tesla as a cash machine. From that angle, SpaceX's financial success is an anchor of stability for Tesla's ownership structure. How should we summarize the tangled relationship between SpaceX and Tesla? Through the lens of first principles, we see that SpaceX is not just a sister company to Tesla. It is the accelerator that pushes Tesla toward its ultimate form. It is the huge, silent giant behind it. Think about it. Without SpaceX, Tesla would still be the absolute leader in embodied intelligence with FSD and Optimus. It would still have an exciting sci-fi story. But because of SpaceX, Tesla's sci-fi feeling does not stop at Earth. It is given a grand interplanetary mission. Because of SpaceX, Tesla's materials science reaches into space-grade stainless steel. Because of SpaceX, Tesla's AI chips gain space as an infinite second growth curve. Because of SpaceX, Tesla's Optimus robots get Mars as their ultimate proving ground. That helps them avoid the cost race to the bottom on Earth. Because of SpaceX, Tesla's FSD gets a global, no-dead zone neural network. SpaceX acts as an extreme external forcing function. It sets performance targets far beyond Earth conditions, radiation resistance, extreme temperature swings, vacuum compatibility, high G loads. These brutal requirements force Tesla's engineering teams to break through existing limits and leave their comfort zone. The breakthroughs forged in these extreme environments are then brought back down to Earth. They turn into a massive technology lead for Tesla's consumer products. That is the real physical foundation under Tesla's trillion-dollar valuation story, not the quarterly sales numbers in its earnings reports. So next time you see a Falcon rocket streak across the night sky, or see Starship blasting a spectacular plume of exhaust on the pad, remember, that same force is also driving the nervous system of millions of electric cars on Earth. When you see a Tesla on the road, realize that it may not just be a car. It is a ground terminal in humanity's blueprint for a multi-planet civilization. That is interplanetary synergy. That is the truth of the Musk ecosystem. It is huge, complex, and full of risk. It is also incredibly fascinating. Is this cross-planet industrial layout just a capital bubble in your eyes? Or is it the solid foundation of humanity's future? The answer may not be in the stock chart. It may be in the starry sky above us. Today's episode ends here. I hope it was useful. If this way of looking at things gave you new ideas, leave a comment and share your thoughts. This is Money Stories. See you in the next one.